The table below represents the height of a ball over time. Determine the recursive rule that models this scenario. Okay, so we're looking at the height of a ball over time. This is a quadratic equation, so we're thinking about a ball going up in a parabola like this. We want to represent the height of the ball over time. We want a recursive rule to define that. So in order to do this for a quadratic equation, what we're going to do is we're going to find the differences between these values. So from 1 to 4, let's retry that. From 1 to 4, the difference is 3. We add 3. From 4 to 9, we add 5. From 9 to 16, we add 7. And from 16 to 25, we add 9. So that's the first difference. Now we can see these differences aren't all common. So we're going to take the second difference, the difference of the differences. So from the difference between 3 and 5 is 2. The difference between 5 and 7 is 2. And the difference between 7 and 9 is 2. Okay. So here's how we do a quadratic recursive rule. The quadratic recursive rule is f of n equals f of n minus 1, so it's always based on the previous term, plus, and then this part, 2x. The 2 there comes just from the 2's that we got right here, the second differences. And then we add one more value to this, and we have to solve for that value. So let's think about this. Let's say I want to find, the fourth value here. I want to find 16. So 16 equals the previous value, which is 9, plus 2 times x, and x here in this case is 4, plus some value here. So we get 16 equals, well, 2 times 4 is 8, plus 9 is 17. And the only way that we can make 16 equal 17 is if this value here is a -1. So we're going to subtract 1, and that's how we get 16. So that means the value that goes here is actually going to, instead of plus -1, we're just going to write it as -1. So this is our quadratic recursive rule that models the height of this ball over time.